For the longest time, we all thought the digital world was basically limitless. It was just code, right? A place where the only thing holding back growth was your own imagination. Well, it turns out the age of AI has just slammed that beautiful digital dream right into a very real, very hard physical wall. And for what, 2 decades, this quote was pretty much gospel. We all believed that software was just going to conquer everything because, well, it wasn't tied down by the messy, slow, physical world. It could scale up, copy itself, and expand with what really felt like zero friction at all. But that's all over now. I mean, definitively over. The whole game has changed. See, the new bottleneck for AI, it isn't the code, and it's not even about the money. It's raw power, the actual electricity that brings all this to life. And that is the new reality we all need to wrap our heads around. To really get what's happening, we've got to grasp one central concept, something that we're calling the gigawatt gap. So here's the absolute heart of the issue. AI's thirst for electricity, it isn't just growing, it's growing exponentially. It's a rocket ship shooting straight up. But our ability to actually generate and transmit that power, well, that's growing slowly, linearly. It's stuck in a world of regulations, permits, and construction timelines that take a decade. This gap you see widening right here. That's the danger zone. That's where the entire future of the AI industry is at risk. And just to be super clear, this isn't some theoretical problem for, 10 years down the road. It's happening right now. And the epicenter of it all is the very heart of the global internet, Northern Virginia. Take a look at this number, 0.76%. In Northern Virginia, the data center capital of the entire planet, the vacancy rate has just collapsed to less than 1%. It is, for all intents and purposes, zero. There is no space left. The whole market is completely sold out. Just let that sink in for a second. Now here's where it gets really wild. Even with this massive construction boom happening, you can see that first bar. Over 2 gigawatts of new capacity is being built. It doesn't even matter, because look at the bar right next to it. Nearly 75% of that new space is already gone. It's pre-leased. It's sold years before the concrete is even dry. You have companies desperately locking in power that they won't even be able to use until 2028, maybe even later. Unless you think this is just a US problem, it is absolutely not. Governments all over the world are slamming on the brakes. In Ireland, they've created what everyone's calling the blockade, basically telling data centers you can't plug into our grid unless you bring your own power plant. Meanwhile, you've got Singapore with the bottleneck, where they're rationing out these tiny slivers of new capacity and only to the absolute most hyper-efficient designs. The world's power grids are closing their doors to AI. So the obvious solution might seem to be, well, let's just make more efficient chips, right? Do more with less power. But here is the great paradox. The next generation of silicon is actually making this whole physical problem much, much worse. Everybody, meet NVIDIA's new Rubin platform. It's an absolute monster. It doubles interconnect speeds, it packs in more advanced memory, but look at the cost, right up there in that top row. A single rack of these GPUs is going to draw up to 160 kilowatts of power. That is enough electricity to power a small neighborhood. And as you can see down at the bottom, trying to cool this thing with air, it's physically impossible. Liquid cooling is no longer an option, it's mandatory. And this creates what we're calling the retrofit cliff. The vast, vast majority of the world's existing data centers, the ones built for a gentle 5 to 10 kilowatts per rack, they are now functionally obsolete, basically overnight. They can't handle the power density, they can't handle the cooling. You can't just renovate these places, you have to gut them. So now we've got 2 classes of buildings in the world, these new AI-ready fortresses and a bunch of legacy shells. So what happens when the physical world gets this tight and this expensive? Well, you get a period of some pretty brutal economic Darwinism, a real shakeout. The AI gold rush is officially over. For all those startups that were built on just putting a simple interface, a wrapper, on top of another company's big, powerful AI model, their failure rate has hit a staggering 90%. Their entire business model, which was built on the assumption of cheap, abundant computing power, has been completely wiped out by skyrocketing costs. And you can see the money is just fleeing to safety. I mean, this chart is stark. That purple slice shows that half of all venture capital dollars last year went to just 0.05% of the deals. We're talking about the huge foundation model companies, your OpenAIs, your Anthropics. The rest of the market, that whole big blue section, is left fighting for scraps. This is creating a hollow middle where only the giants who own the actual physical infrastructure can survive. So, If the public grid can't power their giant ambitions, what's the endgame for the tech giants? Well, they're making an incredibly audacious bet to escape the grid entirely. They are literally becoming their own utility companies. And we're seeing three pretty distinct strategies play out. Microsoft is going for speed. They're restarting the dormant 3 Mile Island nuclear plant. Amazon is playing for scale, planning to build a whole fleet of small modular reactors. And Google is doing what Google does, betting on deep innovation with next-generation molten salt reactor tech. But, and this is a really big but, here's the terrifying catch. As this timeline shows so clearly, AI needs that power today. That demand curve is going vertical right now. But these amazing nuclear solutions, they won't deliver any significant power until 2028 at the absolute earliest, and more realistically, well into the 2030s. So we are entering what we call the dangerous gap years, that terrifying period in the middle where the only thing bridging this massive shortfall is going to be burning more fossil fuels and relying on a dangerously unstable grid. So with the entire board reset by these physical limits, the winners and the losers of this brand new era are becoming crystal clear. So who wins in this new world? It's not just the software geniuses anymore. The new winners are the people who own the physical layer. We're talking about the nuclear supply chain. Those specialized companies that make liquid cooling systems, the real estate folks who are smart enough to lock in huge amounts of power years ago, and of course the businesses that build out our electrical grid. They own the new bottleneck. And the risks, they're just as clear. Those AI wrapper startups are basically facing an extinction-level event. All those legacy data centers are quickly becoming stranded assets. And here's a surprising one. Even traditional industrial companies are at risk now because they're having to compete with AI for every last electron, which is driving up power prices for absolutely everyone. This all leads us to the one fundamental question for the next decade of technology. For the first time in a long time, the main advantage, the big moat that protects a business, isn't how elegant your algorithm is. It's about raw access to energy. So who wins this new race? The master of the code or the master of the calorie?